All right, we are on to a brand new unit on quadratics. And quadratics are just graphs that have a squared term in them. It's our highest power on a graph. And then they make a particular shape. It's a U-shaped graph, which is called a parabola. And it's going to look this way, or we can flip over our graphs, which is going to be more typical when we're looking at real-life applications. We throw something up in the air and it comes back down. The standard form of a quadratic equation is going to be y equals ax squared plus bx plus c, going from our highest power down to our lowest power in order. And then looking at our axis of symmetry, so if we go back to that standard form, we're going to be looking at those numbers. Our axis of symmetry is going to be y equals opposite of b over 2a. So that's how we can find where our graph is going to be symmetrical, because it's a U-shaped graph that we want to be able to know where, if I know one side, then I know exactly what the other side of that particular equation is. These are things that you should have in your notes, and so you want to make sure that you are having those available for you and can be able to find them. Then we're looking at our first equation. So I have your A, your B, your C, and the first thing I'm going to have you do is calculate your axis of symmetry, because again, that's going to give us a good indication of a point on our graph, and it's going to help us out with lots of different pieces. So looking at this particular graph, my A equals, so this is an A, a B, a C. A is a positive 3, B is a positive 6, and C is a negative 4. And so my axis of symmetry, as we said, is the opposite of B, so it's going to be negative 6 over 2 times 3. So negative 6 over 6 equals negative 1. So if I know that that is my x value, I can go ahead and put that in for x to figure out what my y value is going to be. So I'm going to put this negative 1 back up into this equation every time I see an x. So this is going to be 3 times negative 1 squared plus 6 times negative 1 minus 4. So I'm just substituting that in for the x. Negative times a negative is a positive. So 3 minus 6 minus 4. This would be negative 3 minus 4, which equals negative 7. So on my table, and I'm going to kind of put it kind of middle-ish, negative 1, negative 7. So just down one particular point. It's not too far off our graph. We're going to be okay with that. Once I know the axis of symmetry, I can start going out from there, and I'm going to look at my next point on my graph. So I'm going to be looking at our point of 0, and when I put in 0 in for x, that's going to be 3 times 0 squared plus 6 times 0 minus 4. So this would end up being negative 4. 0, negative 4 is part of my graph. Because it's an axis of symmetry, that also means if I went a negative 2, I should also get a negative 4, because my graph should be symmetrical. And so we can try that. 3 times negative 2 squared plus 6 times negative 2 minus 4. Negative 2 squared is going to be 4. 4 times 3 is 12. And then I have a minus 12 here. 6 times negative 2 is minus 12. So I still get a negative 4. So what this is telling us is I don't really have to put in negative 3 and 1. I really only have to do one of them, because if I know what my negative 3 is, then I'd also know what my 1 is. Because 1's a smaller number, I'm just going to go ahead and solve for that one. So 3 times 1 squared plus 6 times 1 minus 4. 3 plus 6 minus 4, or 9 minus 4, which is equal to 5. So if I go over 1, I'm up 5. And I know I'm going to hit over the top of my graph, so I don't have to worry about this particular piece here. Going the other direction, again, I should know that my answer would be a positive 5. I'm just going to test it out for you on this one so you can see that I'm not lying to you. 3 times negative 3 squared plus 6 times negative 3. And again, you can kind of start to see now my numbers are starting to get bigger, so that's why it's nicer to be able to choose. So 9 times 3 is 27 minus 18 minus 4. And then if I look here, that's going to be 27 minus 22, which tells me that I'm also at 5. And then again, I graph those points, and then I can put in my quadratic piece. So it looks something like this. It's a U-shaped. It's just really, really tight. And we'll be talking about what parts of the graph make it kind of look a little bit more. So we're using a table of values, and we're going to be able to get all of our pieces in here. It also talks about our domain and our range, which is just kind of a good reminder. We talked about domain and range when we had exponential equations last semester, so this one just looks a little bit different. Our axis is symmetry, so if I look at my A is equal to 1, my B is equal to 0, C is equal to 3. I don't need my C in this case, but eventually we're going to need that. And sometimes just writing those out. The axis of symmetry, remember, is the opposite of B over 2A. So I have negative 0 over 2 times 1, which is 0 over 2, which is equal to 0. So my x value is going to be 0. And I'm going to put that into my equation. So 0 squared plus 3 puts me at a positive 3. I can put that into my graph right away. Again, noting that my next points, when I have a 1 and a negative 1, whatever I choose to do, they should be the same. 1 squared plus 3 is 1 plus 3 or 4. Negative 1 squared, remember I have to think of that whole term, is going to be 1 plus 3. So this, again, would also equal 4. You are not required to do both sides, but sometimes if something looks a little bit funny. It's looking like it's going to be off the graph, but we just want to try. And again, you would have a choice between 2 or negative 2. We won't have to worry about this last piece because it's off the graph. If we have more space, we would be putting that in. 2 squared plus 3, which would be 4. 4 plus 3 is 7, and that's going to be the same on both of these. 7 is just 1 point up from my graph, so I'm not going to get too worried about it. And then I can look at my quadratic. Domains for these are going to be all real numbers, because my graph will keep going and hit all my x values. Remember, domains are x values. And our ranges are going to be the possible y values. And since this positive 3 here is my highest y value point, and every other point is going to be above it, nothing else is going to go below. It's a U shape, so it's not like it's coming back down. So this is going to be y is greater than or equal to 3. And sometimes on some of these, they will be less than, so just be aware of that, that's kind of how those will look. And then the last one on here is a story problem. So it says the cheerleaders at U of M launch T-shirts into the crowd every time the Gophers score a touchdown. The height of the T-shirt can be modeled by the equation below, where y represents the height in feet and x represents the number of seconds. All that other stuff doesn't really matter. Really what we're looking at is, here's my equation. My A is equal to negative 16, my B equals 48, and my C equals 6. I'm still using the opposite of B over 2A. So it's going to be negative 48 over 2 times negative 16. So negative 48 over negative 32. And I get 1.5. So when I'm putting in that 1.5, that's going to give me a number. And it's not going to, that x value is a little bit harder to find. However, I'm going to just double check. I think I put a y equals. It should say x equals. So sorry about that. It's an x equals. That's because I'm finding my x value of my equation. I'm not going to go back through and restart the whole video to fix that. When I know that, that's going to end up being between a 1 and a 2. So I don't necessarily have to keep going up by 0.5. Once I have that, I'm just going to use the 0.5 in this one here. So this one would be negative 16 times 1.5 squared plus 48 times 1.5 plus 6. So I would just type that in and get that number. It's not as easy to do this one without a calculator. And I'm just typing that into the calculator. Plus 48 times 1.5 plus 6. And I end up with 42. So at 1.5 seconds, I'm at 42. And that is telling me it's either going to be my highest point or my lowest point of the graph. And then if we go ahead and we look at the 1 or the 2, and I'm just going to choose the 1 because it's a lot easier to calculate. Again, I wouldn't do any more 0.5s at this point. I just want to be able to see kind of where we're at here. Negative 16 times 1 squared is just going to give me negative 16. Plus 48 times 1 is just going to be 48. Plus 6. So negative 16 plus 48 plus 6 gives me 38 feet. And that would also be what you end up with at 2. And then I can go ahead and put in, oh, I should have put those the other directions. And that should be a 38. Because they're the same. So let's just move this information over. I know I grabbed that 6. We'll put it back. This here. This should be over here because we should go from smallest to largest. And then we'll move my little 6 back there. All right. So then looking at the next one. 0 and 3. So I'm really kind of wanting to look at, again, once I know 1 point, kind of working my way out. At 0, I'm going to choose to put that one in because it's smaller numbers. And it's going to be just 6 because 0 squared is 0. Negative 16 times 0 is still 0. 48 times 0. And that would also mean that this would be 6. So from here, I can go ahead and graph. This is going to be my time in seconds. And this is the height. And we're going to fill in our last piece here in just a minute. So 0, 6, so 1, 2, 3. We're not going to worry about spreading this out more. But at 0, I go up to 6 and I put a dot. At 1, I'm going up to 38 and putting a dot. At 1.5, so between 1 and 2, I go up to 42 and put a dot. At 2, I'm going up to 38, and again, it's symmetrical. And so then I have a choice between 4 and negative 1. And so I'm going to put this in as a negative 1 because I think it's a lot smaller numbers than the 4 to put into that equation, but you can still choose to put in the 4. So negative 16 times negative 1 squared is just going to be negative 16. Plus 48 times negative 1 is going to be negative 48 plus 6. Minus 48. So this is negative 58, and that would also be, 4 would be if I plug in a 4. And again, because they're symmetrical, you don't have to do them both. That's pretty far down. So where I can look at my graph and know that I'm going up pretty steep and coming down pretty steep. At what height was the t-shirt launched? That t-shirt launching is going to happen at my y-intercept. So that's going to happen right here. And it's going to be launched at 6 feet when x is 0. The maximum height of the t-shirt was 42 feet. And it happens at the axis of symmetry. And then we're not worrying about the bookwork because we do not have the bookwork as it says on here. If you have questions, make sure you're stopping in for office hours.